So, Mr. Bergman, this is going to be one of the simplest videos ever because essentially we're going to be adding things together, right?
Yeah, we're just adding pressure. So it turns out that when gases are in a container and there's more than one gas, the pressures of each of the gas have to add up to the total pressure, right? So if I have a box right here, and in that box I have these gases with the black dots, if you will, and then I've got the red dots. All right, they each add up to the total pressure. It's P1 plus P2 plus P3. They kind of add separately. I mean, like one, yeah. So how would you do a problem like this? Would you make up a problem for us?
Well, yeah. So let me do something that's really simplistic to begin with. How would we figure our combined weight? What would we do?
Add them together?
You wouldn't take your weight and multiply it by 2?
No.
Because that's stupid, right? So if we want to figure out a combined weight, we add your weight to my weight to, if let's say we have 3 other people, we add all of our weights together. Similar when we're dealing with pressure, if we have one gas producing pressure and another gas producing pressure, we want to know how much overall we have, we just add them together.
So it's simple to do these problems, but let me talk about one really important application that we're going to see in our labs. All right, well, let's do the problem first. Yeah, so if I got 3.2 atmospheres of oxygen and 400 torr of hydrogen, what is the total pressure? Okay, got it. Well, the problem is they're not in the same unit, so I have to convert them both to the same units. And he doesn't say what unit to specify, so I'm see if I can solve this problem. I would write out 3.2 atmospheres over 1. Then I'm going to convert them both to torr, just because I can. And then I would say 1 atmosphere on the bottom is equal to 760 torr on the top. So 3.2 times 760 is 2432. So the oxygen has 2432 torr, the hydrogen has 400. I'm just going to take 2432 and I'm going to add 400, and I get 2832, right? $28.32, yeah. Torr.
You mentioned earlier that we could have converted this to torr. We could have converted this to atmosphere
Yes,
as well.
I could have done it either way. Now, let me talk about one important application or implication of this. When we're collecting gas over water, remember how we have the tubs of water, right? And then we put a graduated cylinder upside down in there filled with water. When we bubble a gas in here, let's say carbon dioxide or something like that, and we bubble the gas and we find that we've got, 55 milliliters of gas or something like that. So let's say I did some reaction and the bubbles turned in, they were carbon dioxide. What's the implication there, Mr. Dimitrievich? Something weird's going on, right?
Well, here's the thing. We know that the gas is being bubbled through here.
So the black dots represent like carbon dioxide.
Carbon dioxide, and it's pushed down the water in the container. So up here we have a bunch of black dots. But when these, the simplistic way, and there's more complex ways to think about it, is that when the carbon dioxide is pushing through, there's water molecules there. And as it's pushing through, it knocks some of those water molecules into the air with them.
So the little green dots represent water molecules. So when we ask what the pressure is of the gas inside of here, we have to actually
There's 2 gases, right?
subtract, if you will. Because what you'll be able to do is you can read from the barometric pressure, the total pressure of the day. So let's say the pressure of the day is 760. So we can say the total pressure today is 760. And the pressure of the water is actually can be looked up on a table. So take a look here at this table. This is the pressure of, or the table of water vapor pressures at given temperatures. And then we can then say, well, let's say that it's equal to 24 torr. What would we do to find the pressure of the CO2?
Yeah, and again, this is given 2 variables, solve for a third,
Yeah,
right?
just add this plus this, so 760 minus 24. So that's an important implication that's going to play a role when we do some problems with our next video.
And with our lab as well.
Yeah.
All right, good to see you.